Okay, so in this video we'll be solving a simply supported beam. We will draw the shear and moment diagrams of this simply supported beam. Okay, now this is a somewhat more lain na siya problem, ba? I consider this one of my bonus problems for strength of materials. Now, sa ngayon na case diri, we have a very unusual na load. This is shall we say fractional lang yung exponent. And then basically wala na takabalo kayo unsa tong tsadahimon ani niya. Now, I'll be employing a technique here that is not usually dili ka na usually gamiton or ginapakita kay sa public. Okay? This is something na I just came up with a few years ago. Now, if you want, this is actually a rare opportunity to showcase this. Okay? This sa kuang technique diri. Now, just follow through na lang sa unsang himon. This is point A and this is point B. Now, gusto na ako ni siya imagine na okay? So, doon na siya kabukang techniques. This is just one of them. Now, I'll just try to imagine that this is an concentrated load. And then, I will have, this is Wx times dx. Wx is equal to 9x 1/3. Ba? Times dx dayon. Distance niya gikan diri paingon didto, I don't know. I'll just call this as x. Gusto na ako siya i-solve what is the reaction of B. Now, to solve for the reaction at B, ang himon ani siya is that I will sum up moments at A, set that to 0. And RB dayon, moment arm niya which is equal to 8. And I equate that with WDX. WDX is equal to 9 x 1/3 multiplied by dx. Ba? We have to take note ng iyang moment arm diri. This is actually force. Apoy kulang diri. Have to multiply it with the moment arm which is equal to x. Kuan man ni differentials yung ganan ana di ako integrate. Ang load occurs from 0 to 8 ba all throughout the beam, so this is 0 and this is 8, so I'd say RB is equal to 1/8 0 to 8. 9 times x, this is 9 x to the 4th cube dx. Okay? So 4 cube ana saya diri, that is equal to 1/8 multiplied by 9 divided by 4/3 plus 1 x to the power of 4/3 plus 1, then 0 to 8 din siya, ba? Now, okay, pause lang sa kajot. Okay, continuing on, this should be equal to 1/8 times all of this should be equal to 27 over 56 x 7/3 from 0 to 8. Now, this is equal to 27 over 56 times 8, 7 over cube minus 0, 7 over cube. RB therefore is equal to RB therefore is equal to 432 over 7 kilonewtons. Okay? So, that is how you solve for reaction ng isa sa isa. Now, the next question na sa dendere, how do you solve for the reaction at A? Okay. So, what we have here, kay hulog naman sa din siya na, let's try to sum up the forces in the y direction. I'd say this will be another pamagi na sad. Now, summing up forces sa y is equal to 0. Now, this shear is equal to WDX. Okay? So, WDX going down. RA, however, is also going up. So, we will have something like this. Yes, sir. Yes, sir. Ako na yung balance. RA is going up. RB is also going up. WDX is going down. Now, we cannot handle differentials here. So, I will just integrate this. Okay? Now, further elaborating, RB, we've already solved for that. We have 432 over 7. Now, W is equal to 9x 1/3. This is a dx. This is from 0 to 8. RA plus 432 over 7. This entire integral over here, that should amount to how much? Okay. I think it will take longer if we use the calculator. Ito na lang siya ikuan mano-mano. So, 9 over 4/3 x to the power of 4/3. This is 8. That should be equal to Okay, so the value of this integral over here, that should be equal to 108. Therefore, RA can then be solved as 324 over 7. Okay, so those are the reactions for this beam. Okay, so now that we have solved for the reactions of this simple beam, I would like to move on with drawing the shear moment diagrams. Now, this is not a very conventional na curve, ba? So, tsada sira itong himunan ni saya, magkuha na lang ta. Let's try to derive equations in which we can solve for the values na din na siya sa para ma-model na nato ang kondendani ang iyang shear na diagram. Now, I have the load here. This is actually 9 to the times x 1/3. Now, 9 1/3 x. This is this should be negative. Keep going down siya. I integrate this. I will have integral na siya, which is equal to negative 9 over 1/3 plus 1 plus 1 plus c. That should be equal to 4/3 4/3, then this should be 9 times 3, 27 over 4. X is equal to 4/3 plus C. Okay? So, I have the shear diagram and say, now, when X is equal to 0, how much should be shear? When X is equal to 0, shear should be equal to 324 over 7. So, I just changed this 7. And then I integrate this naman sad. So, that should be equal to negative 27 over 4 divided by 4/3 plus 1. X 4/3 plus 1 plus 324 over 7 times X. Okay? Plus D. Okay? So, I'll just make this out as, ano saan naman sa initial 3? 24 over 4, 27 over 4. Ah, 81 over 28. Negative 81 over 28x 7/3 plus 324 over 7x. Okay? So, this will be my kuna din, mga curves na rin akong gamiton. This is for load. This is for shear. Supposedly, this still has D pa man yun diri, ba? But, I have to know, say moment diri. Moment here is equal to 0 because this is a pin. It's not designed to create a moment na reaction. So, this should be equal to 0. D is equal to 0. So, I'll just have this. Now, next up, I will just plot the diagrams here. I will be finished. Okay? So, when X is equal to 0, how much is shear? 324 over 7. When X is equal to 8, our shear should be equal to negative 332 over 7. You can input this, but that will be the number na magawas gyudayon. Plus ka na is equal to 0. So, this should be equal to, okay? This is small. This is dako. So, ano siya? Now, I would like to grab this naman sad. We need to know what is the value for here when shear is equal to 0. I get this shear equation over here. I set V is equal to 0, and then I'll solve for X. X should be equal to 4.23 4.2375 4.2375. Okay? So this is muna siya tong kundari atong moment atong x-intercept para ni siya. Okay? So I think muna siya tong kundari. So much for the shear diagram. By the way, maximum shear is equal to 432 over 7. Okay. Okay, so next off, we move on to moment. How do you solve for the maximum sa moment? Now, by the principle of maxima and minima, whenever the derivative is 0, that is where the function maximizes. Now, shear is the derivative of moment. So, kung asa mag-0 sa shear, dito mag-maximize sa moment. We already know kung saan siya na-intercept na po din din. It is equal to 4.2375. Now, I'd like to grab that number and I would like to input that number sa kung moment function para ma-plot na ko ni siya ang curve. Now, we have to take note sa denderi that at A, this is a pin. So, pin, 0 moment. At B, that is a roller. So, roller is 0 gyapon ang moment. Now, the only moment na diri, ang maximum pag nato kay naro diri na point, which is 4.2375 from sa tuang leftmost support. If I were to place that number within that koan, that should equal to 1. $112.076. This is kuan dako, so ana gamay gani ana. That's the rule. If gamay ang intercept din nya sa din dako dito din ang vertical. Okay, so the curve should look like this, at the very least. Okay, so this is how we draw the shear and moment diagram for unusual curves. If you have any questions, just kindly comment them on the post or on the video, and I'll be glad to answer them. Thank you for listening.